All right, Unit 4, Triangle Congruence. Lesson 1 is just kind of explaining what triangle congruence is. Not just triangles, but really any polygons. We can apply this to any polygons where we have congruent figures. And so that's what we're going to explore in this lesson. Your job will be to use the composition of rigid motions to show that two objects are congruent. We're going to kind of do this behind the scenes, but really the punchline here is that we're showing that when a figure undergoes rigid motions, the end result is congruent to the original. And likewise, if we have congruent figures, then we know that there has been a rigid motion or a composition of those rigid motions to show that figures are congruent. So we've defined the word congruent in the past with congruent angles and congruent segments, but now we're going to talk about congruent figures. When they have the same size and shape, we call them congruent. If we have a rigid motion or a composition of motions that move one onto the other, we call that their congruence transformation. All of the corresponding sides, this is the big punchline right here, so this is the one, put a little star by this, all of the corresponding sides and corresponding angles are congruent. If their corresponding parts are congruent, then the figures are congruent. If the figures are congruent, then the corresponding parts are congruent. So this is kind of a biconditional statement. It works forwards and backwards. All right, so these are kind of the two highlights. This is kind of the backdrop using Unit 3 to help us understand Unit 4. So these congruent figures will always have the exact same size and the exact same shape, and they are, like we talked about moments ago, either a rotation, a translation, a reflection, and we should be able to tell what has transpired from one image to the other, from one figure to the other. How did we get those corresponding parts to overlap? Now, I'm not going to be super concerned with us writing out the translation rule or the rotation rule, the congruence transformation. I'm going to be mostly concerned with, can we understand which parts go with which parts? All right, that's kind of the big punchline to Unit 3 as far as it applies to Unit 4. So here is just sort of contextualizing these two figures as congruent polygons, understanding them in the context of a reflection over this line M. And so if we have triangle ABC and we reflect it over this line M, we are going to get this triangle A prime, B prime, C prime, or D, E, F. So A corresponds to D, B to E, and C to F. Therefore, these triangles ABC and DEF are congruent to each other. Now, one of the things that's really important, it's really crucial, is just like we would list these in their correct corresponding order, these need to be in the correct corresponding order as well. So if I change the order of these letters, I have to change the order of those so that they're in corresponding order. I could say that we reflected over line M triangle CAB, but if I did that, I would have to say that that would give me triangle FDE. As long as we change the order of these letters, we have to change the order of those. Keep that in mind. If a rigid motion exists, then these triangles are congruent, which means that all of their corresponding parts are congruent. These sides are congruent to each other, these sides congruent, those sides congruent. These angles congruent, those angles congruent. We can see the markings on the diagrams. So here's what I would like for you to try. Given this scenario, are these figures congruent? All right, are these figures congruent? Are these figures congruent, yes or no? All right, if so, write the congruence statement. So when I say write the congruence statement, I mean write the congruence statement. This piece right here is your congruence statement, but I want you to write that, if that's the case, if these are congruent, for example 1b. And also list the corresponding congruent parts. We did that over here. We listed all three pairs of sides, all three pairs of corresponding congruent angles. Can you do that with example 1b? Pause the video while you do that and then unpause. We'll talk about that one in class. So naming the corresponding parts, sometimes we can't tell based on the way that the diagram is drawn. Like these triangles look like they are maybe isosceles triangles, and so it's hard to say which side goes with which side, and we have to read the congruent statement to know which parts go where. So for example 2a, label that example 2a, we need to know that JK corresponds with MN. So JK corresponds with MN. Okay, that's not too hard, we get that. We need to recognize that KL, or segment KL, would be congruent to and correspond to segment NP. All right, those letters go in the same order, and so we'll need to make sure that K goes to N and L goes to P. So KL is going to go with NP, which means that LJ and PM go together. LJ and PM. So listing those corresponding parts, having the picture, shows us that JK is congruent to MN, that KL is congruent to NP, and that LJ is congruent to PM. Those are just the three pairs of corresponding congruent sides. We also have pairs of corresponding congruent angles. All right? So we have the angle that J corresponds to is M. The angle that K corresponds to is N. The angle that L corresponds to is P. So we're going to mark those accordingly, that angle J is congruent to angle M, and we can tell that in the picture. That angle K is congruent to angle N, and that angle L is congruent to angle P. All right? Now the question is, can we do this if we didn't have the picture? So one of the things that we started this item out with was we had to use the congruent statement because sometimes the picture is a little ambiguous. If we can't tell that that these triangles are not isosceles and it matters which side is which, right? The short one's easy to tell, but then these other ones maybe not as easy to tell. How can we do that if we don't even have a picture? And so I'm going to do that for example 2b here. And we can do that either by drawing the triangle, DOG and CAT, or we can just list the parts using the congruent statement. So angle D and angle C, angle O and angle A, angle G and angle T. We can do the angles hopefully pretty efficiently. All right? The segments, we've got side DO that corresponds and is therefore congruent to side CA. And then OG corresponds and is therefore congruent to AT. G back to D, or DG, however you want to say it, corresponds and is congruent to TC. Again, these should all be capital letters. Since we're just doing triangles, I'm just naming these angles using a single letter. We can get in the habit, and we should be in the habit, of being able to, if necessary, write the angle with 3 letters. Here I don't have a picture. We're understanding that there's no overlap here. Triangle dog is over there. Triangle cat's over there. We can name those angles as is. All right, now, this is the part where things get a little dicey because where we're at right now, we've shown that if the triangles are congruent, then we know their corresponding parts are congruent. But the converse of that is true as well. If the corresponding parts are congruent, then that means that the triangles are congruent to each other. So we're going to show that all 6 pairs of corresponding congruent parts are congruent. And if that's the case, then that means that our triangles are congruent. We can start with angles or sides. It's kind of your call. I'm going to start with sides here, and you can do it in a different order if you would prefer. But we are given some information in the diagram here. For example, I know that segment AB is equal to 3, which is the same length as segment ED. I know that that is true information that is given to us in the diagram. All right? Maybe not explicitly stated, but obviously explicitly given. This means that those segments are congruent to each other. All right? This is by the definition of congruent. They have the same length, therefore they are congruent. Segment BC has a length of 4. Whoops. Segment BC has a length of 4, which is the same as the length of segment DC. This is given information, which means that those segments are congruent. They have the same length, and therefore they are congruent to each other. The third pair of sides is side CA, and that is already marked congruent to side CE. This is given information. I don't have to do kind of a 2-step process like I did with this pair of sides, this pair of sides. All right, I can just name that pair of sides there. So we've listed 3 pairs of corresponding congruent sides. Check, check, check. Now let's talk angles. The angles at A and E are marked congruent to each other. Angle A is congruent to angle E, that's given. We are not given that angle B is congruent to angle D. We have some other stuff there. That symbol there, we have traditionally known that that means that those angles are 90 degrees. And that's a couple steps away from what this notation is telling us. This actually tells us that segment AB is perpendicular to segment BC. So since segment AB is perpendicular to segment BC and segment let's see, how do I do this? ED, I want to put these in the same corresponding order. ED is perpendicular to DC, again, given information. I'm going to use the fact that those angles are perpendicular to say that the angle at B and the angle at D are right angles by the definition of perpendicular. This might look familiar to things and statements that we did and statements that we made in Unit 2. So we have to kind of think back a couple months. Sorry about that. Now that we know that these are right angles, I know that those angles are congruent because all right angles are congruent. All right, so I've got this pair of angles there. I've got this pair of angles here. I need the angles around C. So the angles around C are vertical angles, all right? So I'm going to skip over into here, and I'm going to say that angle, I'm going to write it down here if you don't mind, angle BCA is congruent to angle DCE by the vertical angles theorem. You can either write vertical angles theorem, or you can write vertical angles are congruent. Either way that you want to write that. And so that's our last pair of angles. 3 pairs of sides, 1, 2, 3 pairs of angles. And therefore, once I've got all of that information stated, now I get to say that triangle ABC is congruent to triangle EDC by the definition of congruent triangles. By the definition of congruent triangles, if all of their corresponding parts are congruent, then the triangles are congruent. What we can see here, though, is that we made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 steps. I did 11 statements to get us there. But deductive reasoning is sometimes like that, where we have to make all of these statements so that we can show that these figures are congruent. I know that's a lot of work, but there should be nothing new there except saying, hey, I've got all the sides congruent, all the angles congruent. That means that the triangles are congruent. So these are all statements that we should be able to make at this point in the semester. And if not, then hopefully now we understand that, or throughout this unit we'll understand it a little bit more. So let me click on here. Oops, I'm out of the window somehow. So what I would like for you to do is write a proof just like I did, if you can prove that these triangles are congruent. All right, so if you can do that and take 11 steps or 10 steps or however many steps you need to prove that the triangles are congruent, I want you to try to do that. All right? Or if these are not congruent, explain why they are not congruent. So you give this one a shot and let's see how that goes for us. Pause the video as needed, spend as much time as you need to. All right. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. So let's take a look at this. If, and these triangles aren't congruent, but if this pair of angles is congruent and that pair of angles congruent, then that means that this pair of angles has to be congruent. Here's how we're going to explain why this is true. I've got this is x degrees, this is y degrees. If this is x degrees and y degrees also, they are congruent, they're going to have the same measure, then what I'll do here is I'll have a degrees and I'll have b degrees. What do we know about triangles? We know that the sum of the measures of the angles in a triangle is 180. So I know that x plus y plus a is equal to 180. And I know therefore that a is equal to 180 minus both x and y. I know that x and y and b in that triangle have to add up to 180. So I know that b is going to equal 180 minus both x and y. Well, if A is equal to this and B is equal to that, then by substitution, if B is equal to this, then I can put this in place to show that A is equal to B. And if A is equal to B, then these angles are also congruent to each other. That's kind of a quick step-by-step proof there without actually writing out all the steps for you. But this is the explanation on why this is true. We sometimes call this the third angles theorem. Here it is called the corollary to the triangle angle sum theorem. So this just follows from the fact that the sum of the measures of the angles in a triangle have to add up to 180. So if these are the same and those are the same, then these have to be the same. There's not another choice. These have to be the same amount. So we can use that third angles corollary in a proof where we do not know a way or a means to prove the third pair of angles congruent to each other. In the last example, we had a given pair of angles, a pair of perpendicular segments, and so those angles were congruent, and we had a pair of vertical angles. Here, I have that these angles are congruent given, these angles are congruent given, but I don't have any means to show that those two angles are congruent apart from this third angles theorem. All right, so we're going to prove that these triangles are congruent, and we're going to kind of go step by step here. First of all, we're going to state that these sides are congruent to each other. That's given information. PQ is congruent to PS. QR is congruent to SR. That's given information as well. It's marked. Why is this segment PR or RP congruent to itself? Think back. Reflexive property of congruence. Yay! Hopefully you remember that reflexive property of congruence from a couple units back. And now we can talk about angles. I've got 3 pairs of sides. Now I need 3 pairs of angles. The angles at P, we need to name them using 3 letters. I can't say angle P is congruent to angle P. Otherwise that would be reflexive. So I'm going to use QPR and SPR. QPR and SPR, that's given. I'm going to use the angles down here, QRP and SRP. Those are also congruent, given. Notice how I said something, I said QRP and SRP, but I can write those forwards or backwards. And now that means that the angles at Q and S are congruent by that third angles corollary, right? Corollary to the triangle angle sum theorem. So now that I got 3 pairs of sides and 3 pairs of angles, I can say that the triangles are congruent by the definition of congruent triangles. All right, this proof is a little bit shorter because I don't have numbers for the length of the sides or numbers for the measures of the angles. Instead, I can just say, hey, they're given congruent. They're already marked as such. You need a diagram on that to really understand what is happening. Hopefully now you will be able to use the composition of rigid motions to show that 2 objects are congruent.